Asteroid Bennu NASA successful touchdown. Sample has been taken, but the sample return to Earth has just begun its mission. Relief showed clearly on faces of the team of NASA scientists and engineers as they were told touchdown is complete. Then applause a few seconds later for back away burn complete. The most hazardous part of the mission over, seemingly successful, although we have to wait for a few days to hear the scale of the success. Kindly support my Patreon account because YouTube has again demonetized my channel. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below. Monica Grady, Professor of Planetary and Space Sciences at the Open University, on the conversation, reports OSIRIS-Rex for Origin Spectral Interpretation Resource Identification Security Regolith Explorer, or OSIRIS-Rex for short, launched in September of 2016, arrived at its target asteroid 101955, asteroid Bennu, that is, December 2018. The purpose of the mission was to characterize the asteroid, then bring back a sample of it for study on Earth. We know that they had a problem finding a proper space for a proper location for touchdown because the asteroid was so jagged it was like knives sticking up, and the spacecraft would not have been very able easily to settle itself properly to take a sample. Well, finally it did yesterday. The spacecraft spent 2 years circling Bennu, making detailed maps of its surface, learning as much as possible about the asteroid before the next phase of the mission, looking for somewhere safe to land, or rather not to land, but to make a very rapid touch and go visit to the surface, where it would collect fragments of material to return the samples to Earth. It was completion of the touch and go maneuver that prompted the clapping and cheering in mission control. Now, why Asteroid Bennu, and why the relief? After all, this is not the first asteroid that a spacecraft has visited. It's not the first small body that has been landed on. That record is held by the NEAR spacecraft that made a controlled crash landing on asteroid 433 Eros in 2001. And I still remember the emotion and the control room, in Philae landed on Comet 67P Churyumov-Gerasimenko in 2014. The relief was because Bennu is small, only about 500 meters, that's about 1,500 feet across, a fact that was known when it was selected as a target, but it's oddly shaped and it's active, 2 things that were not known. It looks a bit like an old-fashioned spinning top or a rough diamond, pointed at the top and bottom and fatter in the middle. Because it's so small, it was assumed that Bennu would be quiescent, that it would not, for instance, be behaving like a comet and injecting bursts of gas and rocks. But because nothing in the solar system is simple, when OSIRIS-Rex got close to Bennu, it found that the asteroid was throwing small amounts of material from its surface. The particles were less than a centimeter across, and most of them landed back on the asteroid, generally closer to the equator than the poles, which changed its shape over time. One of the consequences of this activity, explained by changes in temperature, fracturing large boulders and breaking up the rocks, is that the surface of Bennu is completely covered in rubble, much more than had been expected. This made selecting a site for sample collection more difficult. Secrets of the solar system. Bennu is a near-Earth asteroid. It has 1 in 2,700 chance of colliding with our Earth in about 170 years' time. It's also believed to be rich in the type of organic compounds that might have seeded the Earth to enable life to arise. Another surprising find that came from the mapping campaign was that Bennu was not only rich in clay material, but that veins of carbonate were present. Clay and carbonates require water, lots of water, so these minerals must have formed when Bennu was part of a larger asteroid. There's no running water there now, but there might be small pockets of ice below the surface. While this ice will not be collected by OSIRIS-Rex, the effects of water should be seen in the material it's gathered. Studying these materials will help us understand the primitive dust from which the solar system grew and the range of organic compounds present. It will also tell us the physical properties of something that might hit the Earth, potentially helping us to stop it. In other words, what kind of material is Bennu made out of so that we can know how to mitigate it and stop it. Now, it was always going to be tricky to collect material from the surface. Any attempt to land would be unlikely to succeed because the low gravitational pull of Bennu would not grab onto the lander and hold it in place. A lander would bounce off back into space. And this is why NASA used a touch-and-go approach. The spacecraft approached the asteroid very slowly, hovering only a meter or so from the surface, that's about 3 feet above, while an arm was extended to touch the surface and collect the sample. It did this by blowing a jet of nitrogen gas onto the surface, which was sufficiently powerful to throw material into the collection canister. The slow approach to the surface took several nail-biting hours, while the collection operation took a matter of seconds. Collection over, and the spacecraft backed away, hence the relief at mission control and the back-away burn complete. Message showing that OSIRIS-Rex was moving away from the surface. And the video we have here is a little GIF by NASA. So this is NASA's little video having to do with the moment that it took the sample. Now, we don't know yet how much material was blown into the canister, and we won't know until it arrives back on Earth in September of 2023. Hopefully, it's enough to be examined. All right. Now, it might be 60 grams, which is the target, or it might be as much as a kilo. An attempt will be made later this week to see how the moment of inertia of the spacecraft, its uniform motion in a straight line, has changed, which should give a first approximation of the amount collected. When the sample comes back to Earth, it will be analyzed by an international team of scientists who will measure all aspects of the material's composition and structure, especially the organic and water contents of the soil. This is when we'll get some answers which will tell us about our own origins as much as about the origin of Asteroid Bennu. Okay, so this is by Monica Grady. She's a professor of planetary and space sciences at the Open University. This is Creative Commons on the conversation. Please leave your comments and thank you for your support.